On July 1, 2025, astronomers using the Atlas telescope system in Chile made a stunning discovery. They spotted a faint object moving far too fast to be bound by our Sun's gravity. Its unique hyperbolic orbit revealed something extraordinary. This visitor came from beyond our solar system. Because of this, it received the designation 3I, making it only the third confirmed interstellar object, and was named Atlas, after its discoverers. By October, this mysterious object had crossed the orbital path of Mars. The ExoMars Trace Gas Orbiter managed to capture distant images, showing a bright, compact cloud of gas and dust, what we call a coma, but curiously, no clear tail. This was the first clue that this interstellar traveler was not going to play by the rules we know for comets in our own solar system. Like a messenger from a distant star, 3I Atlas is showing all the signs of an exotic origin. Its incredible speed, its steep angle of approach, and its behavior all point to it being unlike any comet we have ever observed. You see, most comets we know only become active, releasing vapor to form a coma, and a tail, when they get very close to the Sun, is heat. But 3I Atlas is a rebel. Even when it was nearly 3 times farther from the Sun than Earth is, it was already spewing water vapor at remarkable rates. But here's where it gets truly astonishing. Spectroscopic measurements revealed an inverted ratio of carbon dioxide to water. In our comets, water is almost always the main ingredient driving their activity. With 3I Atlas, carbon dioxide is the dominant force. It's like finding a recipe from another world, where the fundamental ingredients are flipped. This isn't just a minor difference, it's a profound one. And the oddities don't stop there. By analyzing the light reflecting off the dust surrounding the comet's core, scientists found that the dust particles are unusually fine, or have a chemical makeup unlike most comets we've studied. What's even more mind-blowing is that by looking back at old data from the TESS satellite, astronomers realized that 3I Atlas was already active when it was around 6 times farther from the Sun than Earth. Witnessing activity at such an immense distance is incredibly rare, and tells us this object is special. This powerful combination of early activity and a unique chemical composition points to a formation environment completely different from our own. It suggests 3I Atlas was born in a distant, colder star system, with a chemistry we've never directly sampled before. In a very real sense, it's a piece of another world, delivered right to our cosmic doorstep. So, why is this such a big deal? Because 3I Atlas is a pristine, natural sample from another planetary system, and it's the most active one we've ever seen. In our solar system, the water ice in comets typically needs much more heat from the Sun to sublimate and escape. But here, we're seeing a completely different pattern of behavior, one that challenges our fundamental understanding of how comets are formed and how they work. There are a couple of fascinating theories about why it's so active so far from the Sun. One idea is that highly volatile compounds like carbon dioxide or carbon monoxide were trapped deep beneath its surface. As it traveled through space, even the faint warmth of the distant Sun was enough to cause these gases to escape, breaking through the comet's crust and triggering this early outgassing. Another possibility is that the nucleus, the solid core of the comet, is extremely porous or already fractured, allowing sunlight to penetrate deep inside and ignite activity much earlier than we'd expect. Now, we approach the moment of truth. On October 29, 2025, 3I Atlas will reach Perihelion, its closest point to the Sun at about half the distance of Earth's orbit. The intense solar heat will be a critical test, and astronomers are considering 3 main scenarios. First, a dramatic outburst. The heating could trigger a massive, violent release of gas and dust, causing the comet to brighten rapidly and perhaps grow a spectacular tail. Second, fragmentation. The thermal and rotational stress could be too much for the object to handle, causing it to break apart and reveal its hidden interior. Or third, a stable passage. This is considered less likely, but it's possible it could survive its close encounter mostly intact and continue its long journey back out into interstellar space. The coming weeks and months are absolutely crucial. The JWST mission, along with other instruments, will be watching its evolution after it swings around the Sun. Observatories from the James Webb and Hubble Space Telescopes to powerful ground-based telescopes will be tracking every change in its coma, its chemical signature, and its brightness. If it survives its fiery encounter, 3I Atlas could become visible from Earth in December 2025, when it's about 270 million kilometers away. This would be a truly rare and historic opportunity to observe an interstellar object up close. Every new interstellar visitor like this sharpens our skills. We're learning how to detect and study them earlier, from monitoring their first signs of activity to predicting what will happen at Perihelion. This prepares us for future arrivals, and maybe one day we'll even be ready to send a dedicated flyby mission to greet one. Ultimately, this story isn't just about what 3I Atlas is now, but what it was before it began its journey, and what it will become. It's a cosmic artifact, a time capsule carrying information from a distant world, perhaps from a time long before our own solar system even existed. It's a traveler between the stars, and it's defying everything we thought we knew. If you love science, space exploration, and the deep mysteries of our cosmos, this could be the most exciting astronomical event of 2025. Thank you so much for joining us on this journey. Be sure to subscribe and turn on notifications so you do not miss any updates on our interstellar visitor. We'll be heading toward the stars together.